Hello students, welcome back. So now I'm going to show you some of the core libraries that is used in machine learning. The one that I'll be focusing on this session is NumPy, Pandas, and Matplotlib. Matplotlib is used for visualization purposes. So the dataset that I'll be using is Iris dataset. So the first thing I'm doing is importing my libraries, importing NumPy as NP, that's my alias. NP is the alias for NumPy. Likewise, I'm importing Pandas as PD and Matplotlib.pyplot as PLT. I'm also importing this load iris. I'm actually importing this load iris so that this way I don't have to actually read a CSV file. The good thing about sklearn library is that it allows you to view to actually get access to certain data sets that is very prevalent, very common in your machine learning. So load iris is a very common one. Okay, so in this case, I load my iris right here. So I call the load iris, I store the information, all the data inside iris, and then I convert that into a data frame. So inside my data frame, I'm passing my iris.data. So that's an attribute. Data is an attribute of your iris. That will be your data. And then feature names. I'm taking the feature name attribute of iris, and that will be my column names. I'm also adding a target column. So df species would be equal to iris.target. All right. After that, I print my data frame. So when I run this, it prints out the data frame, and this is the data frame right here. So sepal length, sepal width, petal length, petal width, and species right here. So this actually talks about a flower, and so this talks about like what their sepal length, sepal width, all these dimensions are of the flower. And you can see that it has total 150 records, 150 rows, and 5 columns right here. And now let's look at some of the pandas essential commands. So suppose you want to look at the top part of your data. You just want to know how the first part of your data looks like. You can do that using df.head 10. 10 basically specifies, it tells you how many records you want. I want to see the first 10 records. So you can see that it prints out the first 10 records of your data frame right here. It does not print out everything. So you can see that you index 0, 1, 2, all the way up to 9. So this is your first 10 records right here. Also, the next column is over here. Okay, what if you want to take a look at the 10 random samples? So in this case, you can do print df.sample 10, and that's going to print out 10 random samples. And you can see that these are your 10 random samples, sepal length, sepal width, petal length, petal width, and these are your corresponding species for them. Okay, so this kind of gives you an idea. Like you have 2, 2, 0, 1, 0, 1, 2. Okay, so these are decimal, these are like whole numbers, integer numbers, and these seems like fractional numbers, like decimal number data. Okay, what if you want to take a look at the last end of your data set? You can do that too using df.tail. That's going to print the last part of your data set. You can see that it prints out from 140 all the way to 149. So last end right here. Okay, and now let's say you want to take a look at your information, general information on your data set. So you can do that using df.info. This is a pretty useful inbuilt method. What it does, it's going to give you the count also. So for example, it tells you total 150 entries. It also tells you how many columns you have. It tells you total 5 columns. Also tells you each column and what the data type is. This one tells you like sepal length. This is the name of the column, and it is float 64. So that tells me that this is a decimal number. Anytime when you see float 64, that should tell you it's a decimal number. So this is a decimal number. Your petal length is also a decimal number. Right here, species, it's telling you int 64. So that tells me it's an integral number like 0, 1, 2, 3, something like that, but not decimal number. And you can go and check verify too, by the way. You can see that. You see that all of them are decimal numbers, and your species is all whole number right here. Okay, so this actually gives you that information. Also, it tells you like memory usage, like this is consuming 6 kilobyte. And if there are any null values, you can actually identify that over here too. In this case, everything is saying 150 non-null, 150 non-null. In other words, everything is 150 non-null. That means there is no null entries over here. Otherwise, you would have seen a count that would be smaller than 150. And then there is the statistical summary. So df.describe is a very handy tool that's going to that's going to summarize all the numerical information. So when you run this thing, you're going to see your statistical summary of your data set. So in this case, it's telling you sepal length, the count is 150, your average value, mean value is 5.8, your standard deviation is 0.82, your minimum value for sepal length is 4.3, and the maximum value is 7.9. Also, it tells you each percentile. So 25th percentile is 5.1, 50th percentile is 5.8. So some of you who come from a statistics background would recognize what percentile means. Percentile means the, like for example, right here, 50 percentage. It means that 5.8 is your point where 50% of your data is the value of your sepal length is below 5.8. That's what it means. Okay, so these are your statistical summary it provides, and for each one of the columns right here. Also, you can see the class distribution. So for example, species. So you can type print df. In this case, just run a print df species dot value count, and that's going to give you the value count for each one of the species. And you can see that for species 0 there are total 50 records, for species 150, for 250. Everything is balanced. So you have like 0, 50, 150, and 250. So if you go back on top, if you remember, there you go, species, you see that you have 2, 2, 2, you have 0, 1, 2. So it basically tells you that basically everything is like evenly it's basically the data is evenly balanced. Now, Pandas also allows you to rename your columns. So for some reason, let's say you don't like these columns names. You don't want to see sepal, space, length, centimeter. You don't want to see all this unnecessary information. So maybe you want to rename your column to something like this: sepal underscore length, sepal underscore width, like this. You can do that. You can just say df dot columns and specify the column names over here. Now, when I run this, you can see that it actually prints out those new names. So sepal length, sepal width, petal width, and species right here. And all this like extra space in between, space over here, and the centimeter part, all that thing is gone now. Also, Pandas allows you to filter rows. Suppose you want to filter all the rows where petal length is more than 4. That's all you want. So in this case, you create your mask. So mask is df, petal length greater than 4. So after you create your mask, put your mask inside your data frame using indexing. So right here, I'm putting my mask inside the square bracket, and it's going to return me a new data frame. So I'm calling the new data frame as df underscore large petal. And then I'm printing the large petal right here using head. I just want to see the first few records of that. So when I run this, it prints out that information. What if you want to go less than 4? You can do that too. So less than 4, and it's going to print out all the ones that were less than 4. You can see that petal length, which would be right here. You can see that everything is less than 4. So it prints out all the thing. And if I go back and change it back to more than 4, it's going to print out all of them that are more than 4. You can see that everything is more than 4. Okay, sometimes you may actually have to create a new feature. This is part of feature engineering. So suppose you want to create a new feature called petal area. Now, if you remember your petal from your high school math, area is equal to length times the width. So you multiply petal length by petal width, that's going to give you your petal area. So in this case, this is exactly what I'm doing. Then I'm printing my DF head. I'm printing the top 5 records of that. And you can see that now there's a petal area right here. So your petal length, 1.4 multiplied by petal width, which is 0.2. The answer is 0.28. And likewise for rest of them, 1.3 multiplied by 0.2 is 0.26. So this is part of feature engineering. What if you want to drop a column? So let's say suppose you want to drop the same column, petal area. Let's just say you want to drop this. So in this case, you say df.drop petal area, and you specify your x is equal to 1. Basically, you're saying this drop this column, and you're saying in place equal to true. That means take this data frame and drop it inside this itself. And then after that, I print my data frame again, and you can see that now this column has been dropped. And oh, look at that. What happened? Let's just remove this, come over here and run this. And there you go. Now it has been dropped. You can see that that column does not exist over there anymore now. In Pandas, you can also check for missing values. That's very easy. Just run this inbuilt function is null.sum. So that's going to print out the missing value for each and every column. For sepal length, there is no missing values. Sepal width, no missing values. Basically you are seeing all 0, 0, 0. That means there is no missing values. If you see a number over here, that tells you how many are missing values in that particular column. And now the NumPy essentials. So suppose you want to create all your features now. You want to work with only features. So in this case, x equal to df dot drop species x is equal to 1 dot values. What this function doing over here, what this method does is that it takes all this value. It's basically taking all the value that would be this right here. It's taking sepal length, sepal width, petal width all the way. So this is going to be my x right here. Okay, so what I'm doing, I'm just saying that take every data frame, but drop the species column. Don't take the species. And this I'm saying now is going to be my y. And the next line, that would be this line right here. This is exactly what it's doing. It's saying df species dot value. So right now this has become your y, and your x is equal to this right here. So my x now is basically your NumPy array now. Okay, so this is a nifty little trick. So if you have like 300 400 columns, you don't have to type like each and every column name. You can just say df.drop whichever column you want to drop, and the leftover, that would be your x right there. Okay, you want to take a look at your shape of your data. So in this case, your shape of your data would be 150 rows and 4 columns. Well, 4 columns, that makes sense because this is your x, 1 2 3 4, 4 columns right here. So that's your shape of your x. What about shape of y? Well, in this case, it's going to be 150 rows. Okay, let's say you want to print the first 10 values of x and y. I just want to see what this x looks like and what this y looks like. You can do that too. So I'm printing first 10 values, and you can see that it just prints out 5.1, 3.5, 1.4, 0.2. The first 10 values of your x. Likewise, the first 10 values of your y. That would be your target variable. That would be this right here, right here. And now you can perform some basic NumPy operations. Suppose you want to calculate the mean of every single feature. So in this case, you just say np.mean, give your x, and you say x is equal to 0. So that's going to calculate the mean for every single column over here. So in this case, when I run this, you can see that the mean of each feature, the mean of the first feature is 5.84, the mean of the second feature is this, and the mean of the third, and this is the mean of the fourth. Now, if you remember, you can go back and check what was those first feature, and the first feature was sepal length, and sepal width was the second one. So sepal length, the mean for your sepal length is this number. Likewise, this is the mean for the second one. Likewise, you can do the standard deviation for each column. So this is the standard deviation for the first column, for the second, for the third, and for the fourth. Likewise, there's a minimum value. So you do np.min x comma x is equal to 0. That's going to give you the minimum and maximum value. So the first column, the minimum value is 4.3. The second column, the minimum value is 2. For the first column, the maximum value is 7.9. So you can tell for the first column, this that was, I believe, sepal length. The range is from 4.3 to 7.9. For the second column, the values goes from 2 to 4.4. This way you can derive some statistics. This is a very useful function. This is used in scaling. You can also use some Boolean masking. Suppose you want all the samples where sepal length is more than 6. So in this case, create a mask x square bracket, and you say all rows, right? That's what this means, colon. It means all rows, comma, 0. 0 means your sepal length. If you remember, this is the column index. So in this case, I'm saying the first column, which is the column index 0, should be greater than 6. So in this case, sepal length greater than the sepal length should be greater than 6. So that's my mask right here. And then after that, I just print out my x with the mask. I'm printing out the shape. I want to know how many of them are satisfying this condition. I also want to see some of the first 5 records. So the shape of the samples with the sepal length more than 6 is 61 comma 5. In other words, let's just run this. In other words, 61 comma 4. In other words, there are 61 rows and 4 columns that actually are satisfying this condition where your sepal length is more than 6. So maybe I want to take a look at the first 5 samples. So these are my first 5 samples there whose sepal length is more than 6. You can see that sepal length is more than 6, more than 6, more than 6. All right. And now the Matplotlib essentials. So one of the very common that is used in ML exploration is the scatter plot. So in this case, I'm initializing my figure, and in this case, I call this inbuilt function scatter. And all you have to do is pass on your the x-axis and pass on your y-axis. So my x-axis I wanted petal length, and my y-axis I want petal width. So I'm getting these values from my data frame. So specify your x label, specify your y label. By the way, these three information right here, this is optional. Don't have to do this thing. It's gonna still plot. But I just want some descriptive name over there. That's why I'm writing like this. Okay, so when I run this, you can see that it gives me this plot. Let me decrease the size of the screen so it's more visible. All right. Okay, so now you can see petal length and petal width, and you can see that as your petal length increases, your petal width also kind of goes up. Yeah, interesting. Let's do scatter plot with class coloring. So if we already know three different types of species. So I wonder if I can put colors on these species over here. So if I can distinguish each species from the other ones. And this is exactly what I'm doing over here. Let me increase the size now. Okay. So in this case, I'm initializing my figure right here again. And then I'm iterating through each and every species inside the species column. So there are basically, this dot unique is going to return the unique values inside the species. I'm iterating through each one of them. And I'm creating a subset. So I'm using a filter right here. So it's going to create a subset for each one of the species. And then I'm plotting each one of the species for petal length and petal width. And I'm putting some label over here. Okay, and then when I plot that, now you can see, let me now decrease the size. Now you can see your class 0, that would be this right here. Your class 0 is over here, class 1, which is oranges, that's over here, and your class 2 is over here. So by putting these colors, you can easily distinguish. You can find out that, hey, I can actually find my class 0 very easily. Anything that has petal length between 1 and 2 and petal width between 0 and 0.5 is very likely is going to belong to class 0. Okay, this is same as this. The only difference now is I'm just using colors over here. So this way I can see my I can separate my classes very easily this way. You can also do histogram, by the way. So in this case, I'm doing feature. This is called feature distribution. So this is what histogram is used for. Feature distribution. Initialize your figure first. Uh, in this case, I want a histogram of this column, which is sepal length, and I'm also specifying my bins. I want 20 bins. When I run this, it's going to create 20 different bins over here. You can count 1, 2, 3, 4, 5. You can count each one of them. There are 20 different bins. It kind of gives you an idea how your data is moving. So let's just come over here. You can see that your shape of your curve is like this, then it kind of comes down, then it goes up, kind of comes down, and something like that. Okay, so you can also do box plot now. So box plot is for single feature. So box plot generally is used to find out outlier points, stuff like that. So in this case, I'm just doing box plot of length. So by putting the box, and in this case, you just say plt.boxplot, specify your name of your column, and that's it. So it gives me the box plot. Also, box plot tells you the distribution of your value, like how your values are distributed. So most of your data for your sepal length, it lies between over here, which is 5.1 maybe, to 6.4 or something like this. This is where most of your values are lying for sepal length. And these any points that goes on this range or on below this, these are considered to be outliers.